Make a trace table to trace the actions of algorithm 5.1.1 on the input in 84 through 86. Here we have the number 28, and here I have the algorithm 5.1.1 from the textbook. The algorithm starts here by defining q as a and I as 0. So from observation, we can see that the variables we're instantiating and using throughout this program are q, I, and it looks like R is going to be a list, which I'll record below here. So in this context, A is my input 28 here. So we start by saying Q is 28 and I is 0. So we'll record that here. And now let's follow this while loop. This says, while I equals 0 or Q does not equal 0, which both of those are true, then R of I, which is R of 0, that's the first entry in this list, is Q mod 2, which is 28 mod 2, and that is 0. Next, Q is going to be Q div 2, which is the quotient we get when dividing by 2. So if we divide 28 by 2, we get a quotient of 14. Next, I increments from 0 to 1. This says while I equals 0, which now is false, or Q does not equal 0, which is still true, our next remainder is going to be Q mod 2, which is 14 mod 2, which is 0. And keep in mind, I know this is my next entry because now I is 1, and this part of my list corresponds to I equals 1, and this part of my list corresponds to I equals 0. So next we're redefining Q to be the quotient I get when I divide Q by 2, which is 7, and then I is going to increment from 1 to 2. Now the condition for the while loop is still true because Q is not equal to 0. Next, R of 2, which is my next entry on the list, is going to be Q mod 2, which is 1, since 7 mod 2 is 1. Q is going to be redefined as the quotient when divided by 2. 7 divided by 2 is 3 with a remainder of 1. So we record the quotient there. I is going to increment from 2 to 3. The condition of the while loop is still true because Q does not equal to 0. My next remainder, R of 3, is going to be Q mod 2, which is 3 mod 2, which is 1. Q is going to be redefined as Q div 2, which is the quotient I get when dividing 3 by 2, which is 1. And then I increments by 1. Since Q is still non-zero, we define our next remainder. Oops, that shouldn't be there. Our next remainder is going to be 1 mod 2, which is 1. Next, Q is going to be the quotient I get when dividing by 2, and that is 0. I is going to increment from 4 to 5. And now we're in a situation where neither I equals 0 nor Q does not equal 0, since Q does equal 0. So the conditions of my while loop are no longer met, which means I end the while loop. And now my output is R of 0, which is 0, R of 1, which is 0, R of 2, which is 1, R of 3 is 1, and R of 4 is 1. Now, if I wanted to rewrite my number A in base 2, according to these directions right here, A would be the last number in my list of remainders, which is 1, and then my second to last number here, 1, and then we work our way backwards here, all the way until we get to the 0. So A is 11100 in base 2. And again, this corresponds to the number 28, which is in base 10. Thanks, everyone, and I'll see you in the next video.